here comes we are going to have what are the application disadvantages, advantages of capacitive transducer. That is what we are going to see now. And here the advantages is about good frequency response, and it requires small force to operate them. Hence it is very useful for a small system. That is you can just look at here the frequency response of this particular thing. This is actually a magnitude response, this one, and here this is your frequency response. So for this is a magnitude, we are just having magnitude versus omega. So we'll get a graph like this. Phase, that is angle versus you are having like this. So while you are taking off this particular capacitive transducer type, the frequency response is good, the first one. Then second part is it requires a small force. That is whatever the operation you are going to have, it required only a small force which is required, and moreover it can be used for a very small system, so it is easy to carry. The next one is about the disadvantages, that is due to stray capacitance you will have the responses, some delay will be there. This is what stray capacitance effect. So that because of that there will be an error. The next one is in some capacitance the variation it will come like this, so there will be a non-linear nature. So this is what the disadvantages of your capacitive transducer. And because of this particular non-linear behavior, this is only because of the edge effects. Then for application, what are the applications of capacitive transducer? The application number one, it has been used for measuring angular and linear displacement, then measurement of force as well as pressure. We can able to measure pressure and then force, then angular and linear, then for cumulative measurement, then volume, density as well as liquid level measurement. So these are some of the applications of this capacitive type transducer. Angular displacement, then linear displacement, then we can able to measure force as well as pressure, then for cumulative measurement, then volume and density measurement, then level measurement. So we are going to discuss about one problem. A capacitive transistor is made up of two concentric electrodes. So there are two electrodes we have, and the outer dia of the inner cylindrical. In the theory itself we had a discussion, right? One is fixed, the another one is movable. So that is what. So two electrodes, the outer dia of the inner cylindrical one is 3 mm. Dielectric medium is we are using air. The inner of outer one is 3.1. So we have to calculate the dielectric stress when the voltage is 100 volt and the length is 20 mm. Calculate the change in capacitance if the inner electrode is moved through adjacent of 2 mm, and the breakdown strength of the air is 3 kilovolt. So how we can calculate? The first one is you have to calculate the air gap, that is the two electrodes given, right? So one value is 3.1, the another one is 3. So we have to subtract, then only we can able to calculate the length of the air gap between the two electrodes. So 3.1 minus 3 by 2 you will have 0.05 mm. Then we have to calculate dielectric stress. Point number 2, we have to calculate it. So dielectric stress, which is nothing but they have given the value, the length of your air gap is 0.05. So that was calculated in the previous one, and moreover we are having the voltage is 100 volt. So the voltage, that is voltage which is given by the length of your air gap, from which we can able to calculate the dielectric stress. So stress is so 100 by 0.05 you will have 2 kilovolt. Then we have to calculate the breakdown strength. Breakdown strength also given, that is 3 kilovolt. So we have to go into the formula, that is 2 pi epsilon L divided by log of d2 by d1. So 2 pi into, this is dielectric constant 8.85 and they have given air only. So the value 8.85 into 10 power minus 12 into 20 into 10 power minus 3. 20 into 10 power minus 3 is what? Your length of the electrode, L, which is 20 mm, divided diameter d2 is 3.1 and d is 3. So after substituting that, you will get the value is 3.39 33.9 picofarad you will get. Then one more thing is also mentioned, that is shifting distance. So shifting distance is 2 mm. So already the length value is given 20. So for the shifting one we have to subtract it. So 20 minus 2 will have 18. So we have to calculate a new thing, that is what the required. So the new value is again 2 pi EL by log of E into d2 by d1. Only thing is for the value of 18 we have to calculate. So we'll have 30.5. So already you have identified the value is 33.9. So that value minus the new one, that is 30.5. So you'll get 3.4 picofarad. So that is how we are just calculating the change in capacitance. I think you have understand. Okay, thank you.